بسم الله الرحمن الرحيم. أحبائي وزملائي ملائكة الرحمة، القلوب البيضاء وأصحاب البلاطي البيضاء، أطباء المستقبل وحاملين لواء الصحة في مصر. محاضرتي النهاردة مع إخواتي، مش هقول أولادي، هقول إخواتي وأصحابي وزملاء المستقبل، طلبة بكالوريوس الطب والجراحة بالبكالوريوس لمادة الباطنة ومادة التحاليل الطبية. أنا بدرس معاكم دكتورة حمدية عزت، أستاذ التحاليل الطبية وأمراض الدم. فإن شاء الله أتمنى إن المحاضرة اللي فاتت اللي كنا اتكلمنا فيها على الهيماتوبييسيس إن جنرال والإريثروبييسيس تكونوا استفدتوا منها. وإن شاء الله النهاردة هنكمل البلاد فورمينج إيليمنت، هنتكلم على المايلوبييسيس بديتيلز أكتر، وهنعمل فوكس على المايلوبييسيس. كنا اتكلمنا، بحب انا دايما في اي محاضره بعمل فيها ريفرشمنت بالمعلومات اللي قبل كده. قلنا البلاد فورمينج اورجنز، قلنا المين سايتس افتر ديليفري في البوست نيتال لايف هو ايه؟ قلنا البون مارو. قلنا source of the blood and the blood forming elements are the bone marrow. All the blood cells arise from the stem cells which have the ability of self-renewal and proliferation. It is pluripotent. It can give rise to a variety of kind of cells. When committed, it can give rise to become a unipotent cells and become an one element only, one cells. So it is a pluripotent and it is a highly regulated process. This is the picture of the normal bone marrow. You show in the previous lecture there is a fat cells and there is a hematopoietic cells. And I said the microenvironment of the bone marrow are provided for by specific cytokines and growth factors, which is important for growth and commit these pluripotent stem cells to proliferate. What's the term of proliferation, by the way? Proliferation is to mean increase in size, increase in number, okay, sorry. So proliferate to increase in number. We start by one cells, then divide to become two, then the two become four, and else. We have two types of division, mitotic and meiotic division. For the hematopoietic cells, it divides by mitotic divisions, okay? And it gives us the microenvironment of the bone marrow, provides us with cytokines like stem cell factors, interleukin 3, which is pan-hematopoietic cell growth factor and stimulate hematopoiesis, and growth factor like granulocyte colony stimulating factors or granulocyte monocyte colony stimulating factor. So again, stem cell, self-renewal, and it is plasticity, and it commit to a progenitor cells. This progenitor cells, it is restricted. Once it become commit to a specified progenitor cells like birth forming unit erythroid, that means that this cell will take the erythroid lineage. If it's commit to megakaryocytes, that means that this cell will be take the lineage of the thrombocytes. And mature cells, what are the mature cells? Mature cells come from restricted progenitors, and this is the cells that I can find on normally in the peripheral circulation. So in the peripheral circulation I found only the normal mature cells. Immature cells in normal situation I never found. I found it during special disease or bone marrow irritation. So normally the stem cells are present in G0 phase of the cell cycle, non-dividing cells. Upon specific stimulation it can divide. The capacity of self-reproduction is in excess of the capacity of the, as I mentioned before in the previous lecture, we have symmetrical division or asymmetrical division. Asymmetrical division means that the stem cells is divides and give rise to one stem cell to maintain the stem cell pool, and one which are divides into mature blood cells. In case of severe infection or septicemia, I need more white blood cells to defend against the microbe. So these stem cells have a signal which is then transformed into all of the stem cells can be divided, so both of them. So I have symmetrical divisions favor granulocyte production. So both the stem cells are divided into two cells. Both of them are capable of differentiate into mature cells because I need a large number of cells to compete and to defend against this infection. And I mentioned that to revise multipotentiality. Multipotentiality, that means that the stem cells can give rise to several kinds of cells. Okay. So hematopoietic stem cells differentiate into multiple cell lines, proliferate under influence of growth factor present in the reticuloendothelial system and the bone marrow stroma. It is resemble the small lymphocytes. I cannot distinguish the small lymphocytes from the hematopoietic stem cells, but I can know it through specific antibody test. A monoclonal antibody identifies them through the specific cell marker on their surface. This is the stem cells, okay? And I mentioned it's committed either to myeloid stem cells or lymphoid to give lymphopoiesis or myelopoiesis. And the myelopoiesis through granulocyte, granulocyte, megakaryocytes, erythrocyte, monocyte, colony stimulating factors and give rise to myelopoiesis and give granulopoiesis, monopoiesis, erythropoiesis and megakaryopoiesis. Erythropoiesis we discussed before, and formation of mature blood cells through what? Through the stimulation by hypoxia or under influence of erythropoietin hormone from the kidney. Megakaryopoiesis through thrombopoietin. And here, this is our lecture today is granulopoiesis, formation of mature granulocytes, okay, white blood cells, specifically the granulocytes. The hematopoiesis should be in balance between cell production and the cell death. Cell death, yes. Regularly, we have what is called apoptosis. Apoptosis is a programmed cell death. Every cell in our body, it is die by aging. This is physiological. Like red blood cells, it is die after 120 days. This is physiological. And the platelet, it is the lifespan of the platelet 7 to 10 days. This is physiological. There is a balance between cell production and cell death to maintain the steady hematopoietic stem pool. If there is no cell death or programmed cell death and there is increased production, it is a pathological condition. Uncontrolled proliferation, it is a pathological condition known as malignancy. It is maybe benign or malignancy, or benign or malignant condition. So there is a balance. Everything in our body like a scale. Okay, if any one of these come on other hands, so that means there is a failure. So there should be a balance between the production and cell death or clearance. So we mentioned that the bone marrow is present in the long of humerus and femur, and in the flat bone, in, remind with me, remember, vertebrae, sternum, scapula, bone of the skull, and hip. This bone marrow is provided with local environment and the stromal cell, which mediate the hematopoiesis through specific growth factors and like stem cell factors, tumor necrosis factors, interleukins, cytokines. And this apoptotic mechanism and this hematopoiesis according to a specific stimuli. If there is any imbalance in one of these, it will lead to disease. Okay. Hematopoietic growth factors or cytokines, example interleukin 1, interleukin 2, interleukin 3, interleukin 4, interleukin 5, interleukin 6. There is different cytokines and interleukins. Many of them are involved in the immune systems and in inflammatory response. And the one which is focused on hematopoiesis is interleukin 1, interleukin 3, interleukin 4, interleukin 5, interleukin 6. Interleukin 1 and interleukin 3 is pan-hematopoietic growth factors. It stimulates hematopoiesis in all cell lineage. Stem cell factors known also as AKIT ligand. AKIT ligand. Okay. This is a nice diagram. This is the hematopoietic pluripotent stem cells. It is converted upon specific stimulation into myeloid stem cells. Myeloid stem cells have the capacity to differentiate, proliferate, and differentiate into red blood cells, platelet, monocyte and macrophage, neutrophil, eosinophil, basophil. So the myeloid stem cells are multi-potent. This is pluripotent, and the myeloid is multi-potent. Myeloid stem cells, okay. The coliforming unit erythrocyte is unipotent. It gives only red blood cells. Coliforming unit megakaryocyte, it is unipotent cells. It gives only platelet. Coliforming unit granulocyte monocyte is multipotent. It can give rise monoplast or myeloplast upon specific stimulation. This coliforming unit, granulocyte, monocyte, erythrocyte, megakaryocytes, upon specific growth factors and interleukin 5, it can give rise to eosinophil. Upon exposure to interleukin 4, it gives rise to basophil. Lymphoid stem cells give rise to either B lymphocytes or T lymphocytes. The B lymphocytes is deal with plasma cell and antibody formation. The T lymphoblast is give to mature T lymphocytes. Lymphopoiesis we will discuss inshallah later on a separate lecture. So myelopoiesis is a general term for production of blood cell in the bone marrow. So myelopoiesis is regulated the formation of myeloid cells including eosinophil, granulocytes, eosinophilic granulocyte, basophilic granulocyte, neutrophilic granulocyte, and monocyte. These myeloid progenitors can differentiate in the bone marrow into granulocyte. What's the meaning of granulocyte? We know from the science and from the physiology that every cell are formed of nucleus and cytoplasm. The cytoplasm is either contain granules or contain no granules, non-granular cytoplasm. So Granulocytes means that the cytoplasm is contain granules. Okay. During development from hematopoietic stem cells, the early detectable stage in the committed cells in the bone marrow morphologically is the blast. Is the blast cell. What is the meaning of the blast cell? Blast cell is a large cell with a large nucleus cytoplasmic ratio. What is the meaning of large nucleus cytoplasmic ratio? If you heard this term, if you read it in the textbook. Large nucleus cytoplasmic ratio, that means that I have the cytoplasm is a small amount in relation to the amount of the nucleus, the volume of the nucleus. Usually the blast cell does not have granules. And usually I know the blast cell by a specific cell marker on their surface by the use of a specific monoclonal antibody. Nowadays by what is called immunophenotyping. Okay? By cluster of designation or cluster of differentiation. It is detection of a specific cell marker on the cell to know what is this blast. It is myeloblast or lymphoblast or erythroblast, because all of you are students. All of you are studied in the medical school. But I want to differentiate which one in the grade 1, which in the grade 2, which in the grade 3. For example, the grade 1, they are the age of 22, grade 3, 24, or whatever, the mode of differentiation. So all of you are hematopoietic cells. This is the mean that. But according to the specific marker on the cell and on the surface of the cell, we differentiate the cell. This is if you hear the name cluster of designation or cluster of differentiation. So the myeloid progenitor can differentiate in the bone marrow into granulocyte, macrophage. By the way, macrophage is the mature monocyte present in what? Present inside the tissue. The granulocyte also is called polymorph nuclear leukocytes. What's the meaning of polymorph nuclear leukocytes? I just mentioned that. The cells have nucleus and the cytoplasm. These have polymorph segmented nucleus. Segmented nucleus. I have figures I will show you later on the slides. The granulocytes are differentiated into a distinct cell type by a process is called granulopoiesis. So the granulocyte maturation or differentiation by process is called what? Granulopoiesis. So we talk about which kind of cells? White blood cells. Which kind of the white blood cells? The white blood cells which contain granules. What are these cells that contain granules in their cytoplasm? They are the basophil, eosinophil, and the neutrophil. Okay? They are come from what? From the common progenitor cells. Okay? Common myeloid progenitor from the bone marrow. First, we have stem cells, which are upon specific stimulation, growth stem cell factor, interleukin 3, interleukin 1, it commit and become common myeloid progenitors and give rise to myeloblast. The early detectable stage of the myeloid series is the myeloblast. This myeloblast give rise to a promyelocytes. The myeloblast is a cell with large nucleus to cytoplasmic ratio. It have nucleoli in the nucleus, and it is normally does not contain granules, and the cytoplasm is just a rim, scanty cytoplasm. It develop and it mature into promyelocytes. It divides into promyelocytes. This promyelocyte stage is the second stage of the myeloplastic division. It may be larger usually. When the cell mature, it becomes smaller in size, except the promyelocyte. It is maybe increased and larger than the myelocyte stage. It still contains nucleus and contain nucleoli, remnant of nucleoli. It may be have 1 to 2 nucleoli in the nucleus. And the cytoplasm become more abundant than the myeloblast. It contains granules, which is called azurophilic granules or primary non-specific granules. What is the meaning of primary non-specific granules? Primary non-specific granules is granules does not indicate which of this kind of promyelocyte will be differentiated into eosinophil, basophil, or neutrophil. It is pan-specific. It is non-specific. So I will not able to differentiate the promyelocyte if it's come from will be differentiated into eosinophil or basophil or neutrophil. The differentiation stage starts at the myelocytic stage. The myelocytic stage, the cell become smaller in size than promyelocytes, nucleus become to be small and acquire and have a secondary specific granules. The secondary specific granules that give the characteristic shape and the type of the cells. If it's contain azurophilic granules, it will be eosinophil, which is give rise to eosinophil, which is acidophilic granules, and it is coarse red granules. If it's a neutrophilic granules, it will be give rise to neutrophil. If the granules is basophilic, it will be give rise to the basophil. This myelocyte differentiate into metamyelocytes. Metamyelocytes, or the other term is called juvenile. So juvenile or metamyelocyte is the cell or the stage after the myelocytic stage. The cell start to have indentation in the nucleus. I will show you the figure in the next after a while. And the cell already I know that it is will be myelocyte or it is eosinophil or neutrophil or basophil because it have already the specific granules from the promyelocytic stage. Then I have the band. All of this stage till the metamyelocyte stage normally does not pass to the peripheral circulation. It is only present in the bone marrow. So what are the stages that the cell come to the peripheral circulation? From the band or staff or stem. This is the three names: band neutrophil or staff neutrophil or staff neutrophil. It is the C-shaped cell or S-shape or a band shape nucleus. So the nucleus have a C-shape or S-shape or a band. And this is the only cells from these immature cells I can find normally in the peripheral circulation, but does not exceed 5% of the total granulocyte count. Okay, and then the mature cells, eosinophil, basophil, or neutrophils. This is normally I can find in the circulation, but there is special percentage of each one of these. By the way, the normal white blood cells count is from 4,000 to 11,000 per cubic milliliter. Increase in the white blood cells count is called leukocytosis, which increase in the white blood cell count or corpuscle. The term leukocytosis. The term leukopenia is the decrease in the white blood cell count decrease than normal. Not every leukocytosis is malignant. Leukocytosis can be either benign or malignant. Okay. The macrophage come from what? Monoblast. We can return to this figure. Okay. Here, myeloid stem cells, pluripotent stem cells become myeloid stem cells, and colony-forming granulocyte monocytes become monoblast, then promonocytes, and give rise to monocytes. This is monocytes in the peripheral circulation. It is large cells with kidney shape or bean-shaped nucleus, gray cytoplasm, and devoid of granules. Or actually, it have not devoid of granules. All texts said it is devoid of granules, but actually it have a few granules on the periphery. These cells in the peripheral circulation, if it's come into the tissue, it become macrophage and take the name of the take different name according to the tissue where there is settled in. Okay. So hematopoietic stem cells are stage 0. Upon assimilation, it divides